Okay, so let's do some examples where we have to find the nth term of a geometric sequence. Well, now that we know it's geometric, it's definitely not arithmetic. You could check it. It's not going up by a common difference. So since it's geometric, we're going to have to use our geometric formula, which is Tn T1 times r to the n minus 1 power. All right. Now, we're going to be plugging in for two things. Once again, the first term and then the r. Okay, now how do we find the r? Do you guys remember? What do we do, Luther? Yeah, we do T2 divided by T1 to find the r. You could do any two consecutive terms. It does not have to be T2 and T1. You could do T3 divided by T2 or T4 divided by T3. It doesn't matter so long as they're two consecutive terms. But these ones are the easiest because the numbers are usually smallest. Not always, but usually. So T2 is 4, T1 is -1, and therefore my common ratio is, and all that's telling you is that that's what you're multiplying by each time to get the next term. So we know what r is, and we also need to know what the first term is. What is our first term? -1. So now we know what to plug in. We have Tn equals -1 for the T1 and -4 to the n minus 1 for r. And there's your nth term formula. This, just like the arithmetic one, can be simplified. I'm not going to have you guys do it, but it can be simplified. There's a way that you can change the n minus 1 to an n. And for our purposes, it's just not going to be something we're going to need to do, so I'm going to go ahead and let it go. All right, go ahead and write down part B. Okay, so to find T10, all we're going to do is plug it in. So here we go. T10 is equal to -1 multiplied by -4 raised to the 10 minus 1 power. Okay, now we're going to want to use calculators for this first of all. When you do the, well, first of all, we could do 10 minus 1 in our head. That's pretty easy. So let's do that. -1 times 4 to the 9th, and it's -4. Now, when you're using your calculators, my advice to you is use the parenthesis function. This isn't true for all calculators, but on a lot of them it's important. If you don't put parentheses around the -4 when you raise it to the 9th power, it will only do the power to the 4 but not the negative. And on this problem it won't matter. But if I had an even power and you didn't do the parentheses on some calculators, you'd get the wrong answer. So it's important that you put the number in parentheses if it's a negative. So you might want to make a little note to yourself there when using a calculator, put the negative in a parentheses. So let's go ahead and do that. So now we have -1, and after raising 4 to the -4 to the 9th power, we're getting -262,144. And if you multiply the -1 times the negative, you get a positive answer, which is 262,144. So it's 262,144, and it's a positive. All right, so go ahead and write down number 2, please. Number 2 is what it will look like mostly in your textbook. They'll just say find T whatever using the sequence below. Okay, now guys, I kept the numbers here kind of small just to keep things simple. But like if I saw this and it said find the 6th term of the geometric sequence, what's going on here each time? What does it look like happening? It's divided by 3 each time. Well, I would really just divide by 3 2 more times to get the 6th term. I wouldn't go through all this process of using the formula. But I made it small just so you guys can grasp the idea, not so much because it's always going to be that easy. Sometimes it's going to be too big to just work your way up to it. So we're still going to do the formula thing, even though we could totally do it that quick. But if you ever had a question like that on the test, just do it manually. I would. It would save a lot of time. Okay, so I'm going to go ahead and switch slides here real quick. Here's our sequence. We have 81, 27, 9, 3. All right. Well, first of all, we need to find r, which we find by putting the second term over the first. Now, in this case, would it be wise to use the first two terms? Yeah. You could, but check it out. What else could we use? I would use the last two terms because those are smaller numbers. I think that'd be a lot easier. So let's do T4 over T5. But you can still do the first two terms. It would still give you the same answer. 3 over 9 reduces to 1/3. Okay? Now what we're going to do is identify T1. What's T1? 81. So now we're ready to plug it into the nth term formula. So here's the nth term formula. What is T1? What is R? Okay, well there's our nth term formula. But we're not done. It was asking for the sixth term. So what do I do now? You're going to plug 6 in. So T6 is equal to 81 times 1/3 raised to the power of 6 minus 1. 6 minus 1 is, so really we're just doing 1/3 to the 5th power. Oops. Okay, now here's the question. How do you raise a fraction to a power? It doesn't have to be that frightening of a mystery. All you have to do is raise the top number to that power and the bottom number to that power. So let's do it. Okay, so by the way, in case you guys missed it, there was a correction made. It was T4 over T3, not T4 over 5. All right, let's go ahead and finish up our problem. So what do we get if we raise 1 to the 5th power, guys? You get 1. And what do we get if we raise 3 to the 5th power? 243. So here's what we have. We have 81 times 1 over 243. Now the question is, how do we multiply 81 times 1 over 243? Think of 81 as 81 over 1. Multiply straight across. And then what we're going to get out of that is 81 over 243. And luckily, Mr. Bailey's already shown us how to reduce on our calculator. Go ahead. What do you get when you reduce 81 over 243? 1/3. So the sixth term is 1/3.